Hi everyone, this is lesson 10.5, the last lesson of unit 10, and then we'll do a couple days of air review, and you'll be taking your test on April 26th and 27th. It's a Monday and Tuesday. So today we're going to learn how to make box and whisker plots and calculate the interquartile range and determine outliers. Okay. So a box and whisker plot it organizes data into four groups called quartiles. So you've got four groups called quartiles. And it's important to know that a box and whisker plot, it's split by the median. Split by median. I think there's a question in your latest error Edgelastic about an interquartile range. So not rather than the mean. So you're not using the mean for box and whisker plot, you're using the median, the number that's in the middle. So the lower quartile is the median of the lower half, median of lower half, and upper quartile is the median of upper half. And then your interquartile range, which we call IQR, is the upper quartile. I'm going to say quartile upper minus quartile inner, like upper quartile minus inner quartile. So it's kind of like a range, except you're taking the range of the upper and the lower quartiles. So a box and whisker plot, remember, you don't remember what we're looking at here. So you've got a box, and then you've got the median, and the median doesn't always have to be like directly in the middle of the box. It just depends on how your numbers are spread out. So it could be there, it could be over here. And then you've got the whiskers, and the whiskers represent the lowest point and the highest point. So this would be the lowest point, and this would be the highest point. And this is your median. And then here, this represents your lower quartile, and this represents your upper quartile. All right, so we're going to learn how to make one of those, or maybe review if you've done it before. So here it says that the lengths of the songs in seconds of a CD are listed below. Make a box and whisker plots of the song length. So the first step would be to list all of your numbers in order from least to greatest, and then determine your median. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, 10 different data points here. So that means that our median is going to be halfway between the lower half, or the fifth and the sixth number. So that would be if you took 225 and 240 and you average them together. Well, actually, hold on a second. No, these are not these numbers. We still have to average these numbers together. So let's see, our smallest number is 173. So we're going to go 173. I guess we should add up these numbers. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you still have 10 numbers. So 173. And then next would be 179. So we're going to have 5 here and 5 over here. And then 181. 198. And 206 is our next number. And then for your upper half, you've got 239, 246, 251, 257, wait a minute, do we have a 230? We don't have a 239, never mind. That is for the median. So you've got 246, 251, 257, 261, and 295. All right, so then your median is halfway between 286 or 206 and 249. So if you average those two numbers together, wait a minute, we do have 239. Yeah, 239 is right there. I'm sorry. So 239. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I miscounted. We have 11. Okay, so 239 is the median. All right, so anyways, so then your lower half is these 5 and your upper half is these 5. So then for your lower half, if it's 5, then you're going to pick the third one. That would be the lower quartile. So this is going to be your lower quartile, and then 257 is going to be your upper quartile. So lower quartile, upper quartile. Okay, so then they give you this number line to kind of organize everything. So we're going to put a dot on each end for the smallest and the highest number. So 173, it's about halfway between these two numbers. So I'll put a dot here and label 173. And then 295 is close to 300. This is 295. Okay, and then our lower quartile is 181. So that means I'm going to put a line here for our lower quartile. And then our upper quartile is 257, so that's going to be around 255. I'll put a line here for our upper quartile. All right, and then our median is 239, so that's about here by 240. So I'm going to put a line here for our median, and then connect these lines to make a big old rectangle. And then we'll draw lines for our whiskers. And that's our whisker plot, box and whisker plot. So you could also add labels 239, 257, and 181 so that you know what those numbers are. Okay, so then let's calculate the interquartile range. So the interquartile range in this case would be 257 minus your lower quartile, 181, which is 76. So 76 is your IQR. Now, let's talk about how this data is spread out. So the data is spread out. The way you can tell whether it's the concentration of numbers. So this would be clustered since it's shorter. It's the shortest portion of the box and whisker plot. So this would be the most clustered part of the box and whisker plot, which means most of the numbers, well, not most of the numbers, but you've got a lot of numbers between this. Now here, with this part, with the lower quartile, this would be considered to be spread out. So there's a big difference between the lower quartile and the median. And then these ones are kind of just like moderately spread out compared to the rest of them. So this is the most clustered part. This is the most spread out part. So the shorter the quartile is, then the data is clustered or more concentrated in that area. Okay, so let's look at an example here. So we've got box and whisker plots showing the normal precipitation each month in Dallas and in Houston. For how many months is Houston's participation less than 3.5 inches? So if each of these, so this is an important thing to note, each of these intervals represents 25%. Even if it's longer or shorter than the other, each of these represents 25%. And in that case, because you're talking about the median, in that case, 25% of months in a year would be 3 months. Because you would take 12 and divide by 4. So each of these intervals represents 3 months. So for how many months is Houston's precipitation less than 3.5 inches? So here's Houston, here's 3.5. We're talking about this interval here. So that would be 3 months because it's just one interval of the box and whisker plot. Find the range for both cities and explain what it means. So for Dallas, the range would be 5.2 minus 1.9, which is 3.3. And then for Houston, the range is 5.4 minus 3, which is 2.4. So this just means that the Dallas precipitation varies more than Houston. So since it has a higher range. Find the interquartile range for both cities and explain what it means. Okay, so Dallas would be 3.2 minus 2.3, which is 0.9. And then Houston would be 4.4 minus 3.5, which is 0.9. So this means that the cities have the same variation in the middle 50% of the data. And then can you find the mode of the data from the Box-and-Whisker plot? Why or why not? I would say no, because you don't have enough information. So you know these 5 important numbers here. This is like your 5-number summary, but you don't know all the numbers that are in the middle. So we couldn't determine what the mode would be. All right, so let's talk about outliers. So data value is an outlier if it is greater than the upper quartile by more than 1.5 of the IQR, or less than the lower quartile but more than 1.5. I wonder if there would be possibly an outlier in the last example. So let's go back maybe to this example. So is 295 an outlier? So if we were to follow that rule, so the rule said that the data value is an outlier if it is greater than the upper quartile by more than 1.5 times. So if we take our upper quartile, which is 257, and multiply it by 1.5. So 257 times 1.5 is 385. Okay, so 295 then would definitely not be an outlier. So it follows well from the data because it's well within that 1.5 times the upper quartile. So we don't need to worry about that here. And I don't think we would have, I guess we could check here, 3.2. What's 3.2 times 1.5? 3.2 times 1.5, 4.8. Okay, so in this case, actually, 5.2 would be an outlier because if you take the upper quartile multiplied by 1.5, you get 4.8, and the 5.2 is greater than 4.8. So this would be an outlier. Okay, so here the normal monthly amounts of precipitation in Dallas are these, so they give us the numbers. These data were used to create the Box-and-Whisker plot. Which value, if any, is an outlier? Okay, did we just answer? We just answered that question. Okay, so we don't have to answer it again. And there was one more example. So baseball. So in 2004, this Suzuki person earned 101 runs. The numbers of runs he scored against different opposing teams are listed below. We're going to make a Box-and-Whisker plot of the numbers of runs scored. Okay, so first of all, I'm going to list the data in order. So I'm going to do the zeros. So we've got 1, 2 zeros. And then I have 2 ones. And then I have for my 2s, I've got 1, 2, 3, 4. And then I've got for 4s, I have 1, 2. I have a 5 and a 7. I have 1, 2, 3 8s. And now I'm also running out of room. And I have a 9, 2 9s, 9, 9, 11, and 18. I suspect 18 might be an outlier. So let's find out. So first of all, 0 and 18 are going to be our whiskers here. Let's find the median. So we've got, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So if we have 19 numbers, that means that our mean is going to be between the 9th and the 10th one. Or our median, sorry. Well, actually, it'll be the 10th data point. So yeah, it'll be the 10th data point since it's an odd number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this second 4 is our median. So that means this is our lower quartile, this is our upper quartile. or our lower data set. So we've got 9 data sets here, or 9 data points. So that means our lower quartile is going to be the 5th one. So 1, 2, 3, 4, 5. So at 2, we put a line here because that's our lower quartile. And then our upper quartile would be the 5th number in the upper set. So not including the median here. 1, 2, 3, 4, 5. So this 8. And then we have to, I forgot to put a line for the median. And then we'll make a rectangle. So it looks like the numbers are mostly concentrated in this area between 0 and 8. So I am really suspecting that this 18 is going to be an outlier. So let's find out. So we'll take 8. If we take 8 and multiply by 1.5, you get 12. So 18 is definitely an outlier in this case. Okay, so that was all. There's no more questions with this. So Box and Whisker Plots. Now you know. Hope you guys have a great day and a great weekend.